Hello Year 11 Mathematics Advanced students. Today we're starting the new topic of Introduction to Calculus. We're starting off the topic by reading through the terminology page, which is on the first page of the chapter, which I recommend you reading as this is a new topic to make sure that you are familiar with the new terms. So we're going to look at the gradient of a curve today. So the gradient of a straight line measures the rate of change of y, which is the dependent variable, with respect to the change in x, which is the independent variable. So we have seen that we can measure the gradient, which we know as m, of a straight line in several different ways. So we can measure the gradient of m, which is equal to the vertical rise over the horizontal run, which is shortened to m equals rise over run. We also have that m equals y2 minus y1 over x2 minus x1, which you can see over here, where our y2 minus y1 calculates our vertical rise, and our x2 minus our x1 calculates our vertical run. So we can calculate this for the gradient of a line joining 2 points of x1, y1 and x2, y2. We also have m equals tan, which we learnt about in our functions topic, where the line makes an angle theta with the positive direction of the x-axis. We need to remember that when the gradient of a straight line is positive, the line is increasing, and when the gradient is negative, the line is decreasing. So over here we have our positive and our negative. So as we're going up, it is positive gradient, and as we decrease, it is a negative gradient. So straight lines or horizontal line, which are horizontal or vertical lines, increase or decrease at a constant rate, and the gradient is the same everywhere along the line. Let's have a look at some examples. So the graph shows, on the right, shows the distance travelled by a car over time. We want to find the gradient and describe it as a rate. So to find this gradient, we would go m equals our rise over our run, where our rise is that for our graph we rise 400, so from the bottom up, so it's 400 over our run, which is our vertical, and our vertical is 5, so over our run of 5, so 400 divided by 5 gives us 80. So the line is increasing as it's going in a positive direction, so this means that that it has a positive direction. A positive gradient, sorry. So when it goes from left to right, going upwards, it's positive. And we should write a concluding statement as we're finding the gradient, and we need to describe the rate of this, the distance of the travelled by the car. So this means that the car is travelling at a constant speed or constant rate even. So let's change rate for speed. We might write speed in brackets of 80 kilometers per hour. Now the reason it's kilometers per hour is we are vertically going in kilometers, and our rise is in kilometers and our run is in hours. Moving on, we have the graph shows the number of cases of flu reported in a town over several weeks. So this could be like COVID-19, which we're going through at the moment. And we want to find the gradient and describe its rate. So what we're going to do is we're going to go m equals our rise over our run. So our rise in this case is negative, So our rise is 1500. So that is negative 1500 over our run of 10. So it equals negative 150. So if you weren't sure, we can look at our graph and know that it's going in a negative direction, as it is from going from left to right, it is decreasing. So the rise is a drop, so it's a negative. And then we just need to write a concluding statement. So therefore, this means that the rate is negative 150, our vertical is cases, over our week, or the number of cases is reported as decreasing 150 cases per week. Moving on. So the gradient of a curve shows the rate of change of y as x changes. A tangent to a curve is a straight line that just touches the curve at one point. So you'll see over here we have 3 tangents, 1, 2, and 3, and they touch the line at just one point. So the point is on the line, on the line, and on the line. So we can see where the gradient touches a curve at one point. We can see where the gradient of a curve is positive, negative, or 0 by drawing tangents to the curve at different places around the curve and finding the gradients of the tangents. So the gradient of a curve at any point is found by measuring the gradient of the tangent to the curve at this point. We also need to notice when the curve is increasing, it has a positive gradient. When the curve decreases, it has a negative gradient. And there is a turning point when the gradient is 0. So looking at our graph, we can see that the curve increases when we have our positive tangent here, or positive gradient. It decreases when we have a negative gradient, and it's 0 here as there's a turning point as it goes from increasing to decreasing. So for this example, on the curve, we're going to write the signs of its gradient along the curve. So we're starting at on the left-hand side. So where the curve increases, the gradient is positive, and where it decreases, it is negative. And where it's a turning point, it is 0. So we're going to start at our turning point. So turning point over 0 is here. Our graph is increasing all the way along here. So we're going to draw positive signs. And then at our turning point, it changes into decreasing. So draw negatives. So for B, we're going to draw our turning points. So we have a turning point here at 0, here at 0, and here at 0. And so we have it increasing first. Then it decreases. Then it's increasing again after that turning point. Decreases finally. Alrighty. So we find the gradient of a curve by measuring the gradient of the tangent to the curve at different points around the curve. So we can sketch the graph of the gradient values, which we call y equals f dash x, which is the gradient function or the derivative function. So this topic of calculus is all going to talk about the gradient function or the derivative function. Okay, so So let's have a look at some examples. So for example 4, we want to make an accurate sketch of the function f(x) equals x squared on the graph paper provided. So we know that the function of x squared is just a parabola going through the points 0, 0, 1, 1, 2, 4, 3, 9, and through -1, 1, -2, 4, and -3, 9. And so it's symmetrical about the y-axis. So we're going to draw our sketch of our parabola, making sure we go through our points and adding our zeros on the end, and we want to write that our function on our graph. Now what we want to do is we want to draw tangents on this curve where x equals -3, x equals -2, x equals -1, x equals 0, x equals 1, x equals 2, and x equals 3. So then we draw our tangents. So they are straight lines just hitting those points of our graph. This is going well, like so. Oops, that one had a little bit of a kink. So these tangents should not have the same gradient. The only ones that will have the same gradient is the negative version. So as my sketch is not very accurate of, well, isn't as accurate as it should be of the function, it is hard to draw the tangents. So then we can work out what our gradients are. So at x equals -3, our gradient is -6. At x equals -2, our gradient is -4. At x equals -1, our gradient is -2. At x equals 0, our gradient is 0. At x equals 1, our gradient is 2. At x equals 2, our gradient is 4. And at x equals 3, our gradient is 6. So now we want to draw the graph of y equals f(x), which is the derivative of the gradient function. And so how we do this is we just plot the points that we are given when we find our tangents. So we have x equals -3, -6, so that is down here. We have x equals -2, -4, we have -1, -2, we have 0, 0, we have 1, 2, 2, 4, and 3, 6. So that is our straight line that we have created that goes through all of our points. And so this is the function y equals f(x). So it's our derivative and it's a linear function. So now we want to talk about that if we notice that where m is greater than 0 in our previous example, the gradient function is above the x-axis. Where m equals 0, the gradient function is on the x-axis. And where m is less than 0, the gradient function is below the x-axis. So since m, or our gradient, is equal to our derivative, so f(x), we can write the following. So we can say that f(x) is greater than 0, so the gradient function is above the x-axis. So when f(x) is greater than 0, the function is above the x-axis. When f(x) is less than 0, so our derivative, our gradient function is below the x-axis. And when f(x) equals 0, our gradient function is on the x-axis. So these are the main things that we need to know when sketching gradient or derivative functions. When we sketch gradient and derivative functions, we don't have to go into this much depth. This is just to show you the understanding of it. Let's have a look at some examples. So we want to sketch a gradient function for each curve. So first we mark in where the gradient is positive, negative, and 0 on our original graph. So it is 0 at x1, it is 0 at x2, and it is 0 at x3. And then we're going to put in when it's positive and negative. So it is negative before the first turning point, then it's positive up to the second turning point, then it's negative, and then it's positive after the third turning point onwards. So then what we do, so for our f dash x equals 0, this is at x equals 1, x equals x2, and x3. So on the gradient graph, which we're going to draw here to sketch the gradient function, these will be the points on the x-axis. So we want to follow down, and we want to put where x1 will be on our x-axis. We want to follow down where x2 will be, and we want to follow down where x3 will be. So we have just followed that down. So basically where our x3 is, we have followed that down, and that, oops, we wanted that to be a straight line. Okay, and so that's where our x3 should be. And then at x2, we want to follow that down. Oh, that was right on that one. Let me just fix that up. And at x3. So you really want to have the graph above it so that you can draw these lines going down. Okay, so just going to fix these ones up. So this is where our, this is our x1, our x2, and our x3. Then for our derivative is less than 0, this is to the left of x1. So this part of the gradient graph will be the x-axis. So because to the left of this x1, so here, because that is negative, it means our graph is going to start below the x-axis. So that means our graph is going to start like so until it gets to the x1 point. Then we have here that it's positive. So that means our graph is going to go above. It's really hard, hang on. So that means our graph started off negative, then it went positive, then it is, so that's when it's positive, then it is negative again, and then it is positive again. So that means between x2 and x3, it goes below the x-axis, and then at x3, it goes above the x-axis. And so that is what our function looks like. Draw the arrows on each end. And we should write that this is y equals f dash x. So that's how we sketch a gradient, the gradient function for the curve. So you could do it all the same color, but the reason I did some yellow and some pink was to show you when it's positive and when it's negative. Looking at example B, we want to do the exact same thing. So when x is, or when it's 0, we want to put our zeros in, and we want to work out where it's positive, where it's negative, and where it's positive again. So increasing and decreasing. We then want to draw our lines from where our x1 is. And our line where our x2 is, and put them in on our x-axis. That's our x1 and that's our x2. So because our graph starts out positive in this one, that means our graph is going to start above the x-axis. Then it's negative, so that means it's going to go below the x-axis. And then it's going to go above the x-axis again. So our function is going to look like, I'm going to do all the one color. so it starts above, goes below, starts above, goes below, and then it increases again and goes above. So that's what our function looks like. And we need to write that it is y equals f dash x. Okay, so it's pretty straightforward. Finally, we have these things called stationary points. So the points on a curve where the gradient of f dash x equals 0 are called stationary points. So because the gradient is neither increasing nor decreasing, so our stationary points on our curve are where we have a minimum turning point. So this is where the gradient of the tangents change from negative to 0 to positive as we move from left to right. So we have our minimum point here. And then we have a maximum turning point. So that is where the gradient of the tangent changes from positive to 0 to negative as we move from left to right through the point, like this one